Okay, welcome back. Today I want to talk about least common multiples, also known as LCM. So one thing I'm going to recommend, if you have not watched my video about prime factorization, please go and watch that first, because that will really help in understanding least common multiples. So after this video, so we're going to talk about least common multiples, and then also you can find my greatest common factors as well. They all tie into each other. Okay. So we're going to talk about least common multiples. Okay. And I want to start off with, say you had 3 and 4. So what this multiples mean is we would take the old way that I was taught was you would say, okay, 3, 6, 9, 12, 15, 18, 21, and 24. Then you would do the 4 the same way. You would do multiples of 4, 4, 8, 12, 16, 20, and 24 until you hit a common number. Well, take a look at this. We do have a 24, and I stopped at 24, but that is a multiple. That is not the least common multiple. The least common multiple would be, if I go all the way down, are these right here are 12. Now I'm going to show you how to use prime factorization to get 12. So here's my 3, and here's my 4. Now 3 can only be broken down to 1 times 3. Now 4 is going to be broken down to 2 times 2. Now what we want to do is, you do not want to include 1 because 1 does not do anything. But what you want to do is you look at both sides. And I always like looking at the smallest number first. So I've got 2 2's here. I have 0 2's over on this left side. So that means I'm going to start off with my least common multiple is going to be 2 times 2. Now, my next number I'm going to look at is 3. Well, I have a 3 here, but I have 0 3's over on the right side under the 4. So I'm going to use that 3. Now notice when I multiply these together, 2 times 2 is 4, times 3 is 12. That's the way how you would approach getting the least common multiple from using prime factorization. So let's use another example. And at any point during this video, you can always stop it and pause it and go back and do these examples on your own, and then come back and check to see how I'm doing it. Okay? So maybe we have the numbers. Let's do, and I'm just making these up. How about we do 6 and 8. So 6 can be broken down into, remember, you do not use 1, 2 times 3. 8 can be broken down to 2 times 4. Now, the 2 times 3 cannot be broken down anymore, but I can break down the 4 to 2 times 2. Now, I'm looking at the smallest number first, which is 2. I've got 3 2's here, but only 1 2 here. So I'm taking the 1. It doesn't matter which side it's on. And sometimes you have the exact same amount. You do not count and say you've got 4 twos. You just use the one that you see the most. In this case, it is 3 twos. And then we've got a 3 here, but we don't have any 3s over here, so we use a 3 right here. And now we go ahead and we multiply these. Two times 2 times 2 times 3, and you should get 24. Now, I'm going to do this one other time. So let's just look at this. 6, 12, 18, 24, and then 8, 16, and 24. And look where they have right here, 24. Now, let's use maybe 12 and 15. Okay. Twelve can be broken down to, I'm going to use 3 times 4. And I'm also going to use, 3 goes into both, 3 times 5. Now, 3 cannot be broken down. My 4 can be broken down to 2 times 2. My 3 and 5 cannot. So now what I'm looking at is this. My smallest number is 2, and I've got 2 of them. But now watch this. I've got I got a 3 here and a 3 here. So I just need to use one of them because that's the most. And then I've got my 5. Now, if you multiply these together, you get 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. So now let's do one other one. Let's maybe do a complex one, maybe 24 and 36. Well, no, let me take this back. Not 36. Let's do 34. Okay. Now, 24 can be broken down. Now, I'm trying to think about what numbers can go into both. Well, I know 2 can go into both. So 2 times 12. 2 times 17. Well, the 2 and 17 cannot be broken down anymore. So then I can break down my 12 into maybe 3 times 4. And then the 2 cannot be broken down anymore, but the 3 cannot either, but the 2 can be broken down to 2 times 2. So now I'm looking at the smallest number, which in this case is 2. I've got 3 on one side, 1 on the other, so I take the one with the most, which is the one with the 3. And notice this, I've got 1 3 here, but none over here, so I have to take a 3. And then my 17. So when you multiply 2 times 2 times 2, you get 8. 8 times 3 is 24. And then if you multiply 24 by your 17, you get a large number. You get 408. So these are some examples how to use prime factorization. But now what we can run into, and notice I've used some larger numbers. Now, just do a quick recall. If you did 24 and 34, think about this for a second. You do 24, the multiples to get 408. That's why the prime factorization is very beneficial, especially with numbers that are kind of larger and odd. So number 5, let's look at, let me make one up on 5. Let's say we had 12, 15, and then 18. So now we're dealing with 3 different numbers. Okay? We still break them down the same way. You could break that down to 2 and 6, and then 2 times 3. 15 is just 3 and 5. This right here, you may say 2 and 9, and then 9 can be broken down to 3 and 3. Now in this case, what we're looking for is the least number. Well, of each one, or of the smallest number first. So you look at 2. I got a pair of 2 here, but only 1 here. So I'm going to just use the one with the most. I've got 1 3 here, 1 3 here, but then I've got 2 3s here. So I'm going to use 2 3s. And finally, I've got this 5 that's all by itself, so you have to use 5. So then when you multiply 2 times 2, which is 4, 4 times 3 is 12, or 12, 12 times 3 is 36, and then when you say 36 times 5, you should get 180. So that means all 3 of these, if you multiply these out, the first multiple they have in common is 180. Now I'm going to do one more of these. Like I said, you can always pause and go back to see my step-by-step. Maybe we will use 18, 24, and maybe 36. $18 can be broken down to 2 and 9, which can also be broken down into 2 times 3 times 3. 24 can be broken down to maybe 3 times 8. And then the 8 can be broken down to 2 times 4. And then the 4 can be broken down to 2 times 2. And notice I'm putting them all in the same lines and separating them by the multiplication dots. And finally, 36 can be broken down to 6 times 6, which is 2 times 3, and then another 2 times 3. So in this case, my 2, I'm looking at my 2, I've got 1 2, 1 2, 3 2s, and 2 2s. So I'm going to say 2 times 2 times 2. I'm going to use 3 of them. Now I'm going to look at my 3s. I've got 2, 1. I also got 2, so I've got 1 that's tied. So you still take 2 of them. So you'd say 3 times 3. So now in this case, when you multiply 2 times 2 times 2, you get 8. And then 3 times 3 is 9, so 8 times 9 is 72. So I want you to thank you for listening to prime or least common multiples by using prime factorization. And if you go back here up at the top again, like I said, go back and review prime factorization. This lesson was least common multiple, and then you can also use what I've talked about now to finding the greatest common factor, or the GCF. Thank you for listening.